Hey all, Steve Cyros here. I want to walk you through calibrating the Libs, the laser that picks up our lithium counts. Does need to be calibrated fairly often. In fact, we mandate once a day, and we typically do every time we shoot, especially if it's an important shoot. I'm going to just show you how easy that is. I'm going to try to do this with one finger, so bear with me. One finger, there we go. Lost it. Geochem mode. We're gonna skip warm up. Let's see if I can do it this way. Let's see. Okay, normally when you have two hands, this is easy. There we go. We're doing a quick calibration. This is that the machine does internally. It'll actually move the laser designator into an internal target. We see that it passed. It's just a 3/16 stainless steel ingot of a known makeup, and the software in the Libs holds that result. And when it runs the calibration, the self-calibration, if it deviates too much, it'll tell you it's out of calibration and it's got to go back to the factory. And when you're in calibration, it's as simple as, you know, maybe 15 seconds. Now we're going to take it a step further. We've got a known sample of lithium. This is basically to calibrate some of the lighter metals. Let me show you what I'm going to do. I'm just going to run it like a regular test. Ooh, low gas. Okay, we've replaced the argon gas. I'm going to run just a pegmatite run here on this known sample. And boom, 1.1%. And if you look at, this is a 1.15 with a deviation of, oh, it looks like less than. Hey guys, I'm just testing this with you. Again, to see, I'm failing miserably on the video, but I do want to show you that I am using the test sample that Stantec referred us to, and we are falling in perfectly. I'm going to grab another one here. Let's just pick a spot. Try to run it for you on camera. And this, you know, this is the process we do in the field. Nothing different. Just 114 degrees out there, and okay, I'm gonna shut my trap and let you check that reading out. You've got a plus or minus 4%, but you're looking at 10%. That has not been, well, again, I'm gonna shut my mouth. 4% plus or minus, so you could be looking at a 6 to a 14%. Let's just shoot it again, same spot, just so you can see. Let me see, I'm trying to stretch my arms in front of the camera so you can watch me actually shooting it. What does that say? No sample detected. All right, I didn't have it flush. It's not a regular shape, so if you don't have it right up against the collector, it doesn't think the sample is there. Let's try it this way. Okay. Again, I'm going to shut my mouth, but I'll guarantee you have not seen that kind of number before. Now let's just for kicks, let's just run another, let's just make sure on a calibration, on camera, let's run another batch of this known lithium sample. Again, we're at the I think it's 1.6, 1.5 is what we're looking for. So I've done exactly the same thing. I've just taken some of that powder. I'm gonna match it up to the laser output on, see what I'm doing? On the Libs. And I'm gonna shoot. Just like I was shooting rock, I'm gonna shoot that powder. And now we know if the calibration's been tampered with or adjusted. If we don't see something like 1.5, 1.6, you know it's off. By the way, you see the end result is it burns up that little thin layer, and what you've got is 1.16. So beyond a doubt, the machine is in calibration. Let's just try cleaning up any residual. It's sealed. There's a glass housing, so nothing gets inside the unit. Let's just try a different sample. Haven't shot this one yet tonight. Looking for a flat surface, otherwise it doesn't detect that sample. And let's see what we get. I think that's flat. %. So we know, and by the way, these are consistent with what I was detecting earlier, so that's why I'm comfortable. I'm going to shoot again. That, by the way, was the same spot. And it just goes to show you it's a surface reading, so we went from 1% to almost 3% in the same spot, but we could have been off by literally the width of a human hair, and that can be enough to make a difference. Let's try one more. Again, get it positioned so you can watch it as I'm shooting. Oh, it's not finding it. That's my fault. Try again. And same thing, 1.9. So one last shot for you on camera. Just again so you can watch the process. Let's try right here. I'm trying to show you the screen as I shoot it. And that's what I'm talking about. 9.53% lithium. So before the scientific world gets turned upside down and says we're doing something wrong, or the device is not in calibration, or you're not calibrating with a known standard, let it be known that we just did that on camera. And when you see some of these readings that will likely get published in the near future, you'll know exactly how we obtained them, and you'll know how accurate they are. That was my goal. You stuck with me to the end. Thank you. Again, not meant to entertain, but I did want to show you the process from start to finish. Stay tuned. I think it goes without saying we've got some exciting things coming to the naked eye. What I want to do today is possibly employ a method of taking one of these samples one step further and actually crushing it up. There's always a lot of talk about shooting averages. The only way with a surface device like a Libs to get anything other than a surface reading, because that's the only access that the actual device has is to the surface, the only way to take it deeper is to crush this material up into a fine powder, mix it up or homogenize it, and then shoot it. And that will have the effect of averaging what was on the surface. For, you know, picture if this was you know, a gold nugget on one side and it was embedded with rock on another. You on a surface reading are going to shoot gold if that were gold, flip it over, and you're not going to shoot gold if there's rock on the bottom. So the idea behind that is if we're looking at an ounce per ounce or an ounce per ton conversion in the field number, the way to do it is to homogenize this, get an accurate reading of everything that's inside the rock, and powder it, and then get several more, you know, half a dozen, 20 more averages, and that's going to give you a much better picture of what you're actually dealing with. So I'm going to start that process with just let me get this camera set up. Just me filming, sorry. Let's just shoot a couple of, you were with me the other day when we did this. Let's just shoot some readings, and just so you know what we're dealing with this particular stone. Blind 4.8 Libs. Of course we see potassium and everything else. We're just not interested in that right now. Just going to move this. Just want to get a few surface readings for you so you can see what we're dealing with. Guys, now see, that's exactly illustrating my point. I just moved that ½ inch and I went from showing lithium to now ND or non-detected. Just goes to show you, you can literally move a hair's width and be on the lithium or off the lithium. Another reason why pulverizing this is going to give us a much better number. Here I'm back on 4.09%. I'm just taking a few shots. Just want to see if we can get a good feel for what's in here before we break this up. And another non-detected. We find someplace we haven't hit. Okay, this is going to illustrate my point even better. So let's just see what a difference. That's 18.91% of lithium with a plus or minus 3%. So you're talking statistically 15 or 16% all the way up to, what is that, 22. That's virtually unheard of. Let's see if I can duplicate that. I think I'm shooting in what I believe is the same spot. And this will just go to show you whether I'm right or not, and I got it on the same spot. And I pretty much did. 18.94. So if I just move that, I'm just going to move it a couple of centimeters. That can go from, I was actually showing 24% on there for a second, but 18% down to, so there's 12%, 12.38%. So this is going to perfectly illustrate my point. I'm going to take this sample now, and we're going to bust it up. Let's turn it into a powder, just so you can see that's all that's in there. I'm afraid of dropping the camera. Trying to do it with one hand. Okay, not quite powder yet. Interesting that it's very crystally. I guess that's to be expected. Every time I bang that, my camera's dropping. But now we've got certainly a powdery consistency. I don't know if you can see. Let me get something to, well, let's do the old scientific method. Okay, so that's what we wound up with. Not exactly powder, but watch this. So we didn't certainly get any big double-digit numbers again, but we're seeing lithium now most likely as an average of what is in that rock, because that process of crushing that mixed that up. We're probably seeing a more realistic number. There we go. I'm going to shoot this a few times, and now we can probably realistically take an average here and feel confident that that is literally an average. Look at that deviation. So now we're back up to 5.7 just because I've moved it. $8,300 ppm. Just shooting at different spots. That does seem to be the consistent amount. Gonna get a couple more readings. And then what I can do is I can average all of those. Back in 1.84% range. Let's try one more. There's a 2100 ppm. So I'll do one last. So you kind of see what a difference having the whole rock broken up is making. And now we'll even take that a step further, and there's a more realistic number again, and we'll take an average of all these readings, and that'll give us a much better statistical number of what we're dealing with here. But you can see, mix that up really good, blend it, which is the idea. And of course I'm not doing the best job of that, but you know what? That's good enough. One more shoot. And there we go. And that's how it's done, even when you're in the field, because this can actually travel with you. Now we've got a smaller mortar and pestle, and then you've got these little tools that will let me actually pack that into what they call a pill, get it hard packed just like an aspirin, and much easier to keep that together when I'm shooting multiples. But just kind of wanted you to see that process online. Thanks for sticking with us. Stay tuned, some exciting stuff coming.